In number 15, we're told that two lines intersect at a point, point A. We want to find its coordinates. So let's jump into the parametric versions. X equals -1 plus 5s. X equals 4 and no t's. I can make those two things equal to each other right off the bat. 5s will be 5, and actually this one might as well solve it when we're at it. So s is 1. Already got ourselves a start. Yeah, let's do the y's. Y equals 3 minus 2s, and y equals -1 plus 2t. So we'll make the same equation with our y's. So we get 3 minus 2s, -1 plus 2t. We're just going to simplify that. So bring the s to the right side to make it positive. 2s, 2t, and we'll bring the 1 over here, becomes a 4, right? And then we'll do the same thing with our z's. Our z is 2 plus 10s, or z is 1 plus 11t. Make them equal, so 2 plus 10s, 1 plus 11t. Keep our s positive, and bring the 2 to this side. It'll be 1 minus 2, which is -1. Now we've already solved for s, so we can pick any of the other two equations to solve for p. So let's put into this one. So s is 1. So we'll get 4 minus 2 equals 2t. In other words, 2 is 2t, so t is 1. And we always want to do our check, so use our third equation as our check. 10 times s, so 10 times 1, minus 11 times 1, -1, and sure enough, I get -1. So we know it works. So we know that when s is 1 and t is 1, we will find our POI, our point of intersection, which is point A in this case. So let's find it. Just to point out, x is 4. We already know that. You don't need to resolve that one. We can pick either of our two equations for y. So y will be 3 minus 2s, but s is 1. So in other words, y has got to be 1. And z will be 1 plus 11t, but we know what t is 1. So 1 plus 11 is 12. So our POI, or point A in this case, is 4, 1, 12. Okay, in part B, determine the vector equation for the line that's perpendicular to the two given lines and passes through A. So perpendicular to 2, that's back to our cross product idea. So for doing part B, we want to find the normal. So we need the cross product of 5, -210, and let's write that down. 5, -2, and 10. That's what one of our directions was. The other one was 0 to 11. 0 to 11. And I want the vector equations perpendicular to both. So I'm taking my cross product. So this is the direction vector of our new vector, right? So our direction vector, is called A for simplistic sake, will be M cross T. So the vertical form, -2, 10, 5, -2, 2, 11, 0, 2. We'll get a cross product of -22 minus 20, 0 minus 55, and 10 minus 0. In other words, -42, -55, and 10. Our book often uses the positive version of that. These numbers can't really reduce, right? You can't divide them all by -10 there. You can't reduce them all by dividing by 2. So there's no real simple version of that. So the vector equation for the line that passes through point A would be, well, what was point A again? Point A we just figured out was 4, 1, 12. So our vector equation will be our point, 4, 1, 12, plus some parameter, and in the direction of 42, 55, and -10. That's the line.